Alright, on this video we're going to look at more practice with these patterns that we looked at in the previous video. So we've got a pattern of tiled shapes. They're just rectangles. We are going to try to figure out how many tiles would there be in the 10th figure, the 100th figure, and then what about the nth figure. So in this first one, the first shape, the first rectangle, just has 2 tiles in it. So we'll just write a 2 here. The next one has 1, 2, 3, 4, 5, 6. This has 6 tiles in it. The next one has 4, 4, and 4. That's 12 tiles. And then next we've got, let's see, 5, 5, 5, 5. That's 20 tiles. So there's a couple ways to do this. We could look at the differences. This goes up by 4. This goes up by 6. This goes up by 8, so you can probably safely assume that the next one goes up by 10. So in the 5th shape, there are going to be 30 tiles, and then we go up by 12. And so you just keep doing this pattern until you get to the 10th, which wouldn't be that bad. The problem is the 100th figure, it's going to take too much time, and then the nth figure, you're not going to be able to figure that out using this pattern. So let's look at it a different way. So what I notice here is we've got a rectangle, and it's 2 across, and it's 1 tall. On the second shape, it's 3 across and 2 tall. On the third shape, this is the third shape, this is, I'm trying to emphasize that, is 4 across and 3 down. That's a 3. On the fourth shape, it's 5 across and 4 down. So on the 5th shape, it's probably going to be, we'll follow this pattern, it's going to be 6 across, because this number across the top is always 1 more than whatever term it is. So on the third one it's 4 across, on the second one it's 3 across, first one it's 2 across, and so on. And then how tall it is going to be 5, because it's going to be the same as whatever number term it is. So on the fourth one it was 4 tall, on the third one it's 3 tall, on the second one it's 2 tall, on the first one it's 1 tall. So on the fifth one it's going to be 5 tall. And that is 30, and that's what we said we should expect. So on the 10th one, well, here's what I want you to do is pause this and see if you can answer these 3 questions. And then I'll run through it and you can check and see if you got the right answers. So on the 10th one, it's going to be, well, it's always 1 more, so this is going to be 11 across the top. And then it's going to be 10 across the side. And that's a 10, not a 16. So 11 by 10, that's going to be 110 tiles. So for the 10th figure, 110. For the 100th figure, across the top, we said it's always 1 more, so it's going to be 101. And then on the side, it's going to be 100. So it's always going to be 1 more across the top and exactly that term on the side. So it's going to be 10,100 tiles. And then lastly, for the nth figure, across the top, it's going to be 1 more than n. So it's going to be n plus 1. Then across the side, it's just going to be n. So the area of this rectangle is n plus 1 times n. Then we distribute that n in. I mean, you could leave it the way we have it here, or you could distribute it, and so the answer is going to be n squared plus n. That's going to be the general formula. And if we check that out, if we look at, let's say, the 4th figure, 4 squared plus 4 is 16 plus 4, that's 20. And on the 4th figure, it was 20. All right, so that's the first one. That one was kind of an introductory one. Let's take a look at the second problem. This one's a little bit different. It's not nice, clean rectangles. It's these weird shapes here. So on the first one, it looks like we have 5 The second one we got 1, 2, 3, 4, 5, 6, and then 2 in the middle, so 8. And the third one we've got 1, 2, 3, 4, 5, 6, 7, 8, and then 3 in the middle, so 11. Here we got 5 on each side, and then 4 in the middle, so it's going to be 14. So same question. What's the 10th figure? How many tiles are there going to be in the 10th figure, 100th figure, and the nth figure? So once again, try doing this on your own. Pause the video, see if you can get it, and then replay it, or start playing it again and see what you get. Okay, so the 10th figure, well, let's try to figure out a pattern here. I kind of helped you, give you an idea of what it was. On the first one, there are 2 towers of 2, and then 1 in the middle. Okay, let's think about that. Here, there are 2 towers of 3, and then 2 in the middle. On the third one, looks like there are 2 towers of 4, and then 3 in the middle. On the fourth, there is 2 sections of 5, and then 4 in the middle. So if you noticed, these side sections are always 1 bigger than whatever term it is. So if it's the second term, it's 3 and 3. If it's the third term, it's 4 and 4. If it's the fourth term, it's 5 and 5. And then this middle term, or this middle section here, is exactly whatever term it is. So there's 2 extras in the middle here, 3 extras in the middle, 4 extras in the middle. So on the 10th figure, let's see if we can think about how big this would be. Looks like we would have, where did my mouse go? There we go. We would have 2 sections of, well, let's see. It was always 1 bigger than whatever term it was, so it'd be 11 on each side. And then in the middle here, it would be whatever the term is. So if this is the 10th term, there would be 10 tiles in between these 2 sections. So it'd be 11, 10, 10. We add those 3 up and we get 32. So there'd be 32 tiles in the 10th figure. All right, how about the 100th figure? So it's going to look just like this. We're going to have 2 sections of, and it's always going to be 1 bigger, so it's going to be 101. And then in between is exactly whatever term it is. So once again, it's the 100th figure, so there's going to be 100 tiles in there. So 100 plus 101 plus 101, and that's going to be 302. Okay, how about the nth figure? So this is going to be, let's see, we'd have 2 towers, and each of these towers, those are supposed to be nice rectangles, each of these are going to be n plus 1 long. And then in between, this is the nth term, this is going to be n long. So add these up, we get n plus 1 plus n plus n plus 1. And we get plus 2, and then there's 3 n's. So it's going to be 3n plus 2 is going to be our expression to find any term. So once again, if I said, how many are there in the 67th term? We'd go 3 times 67, and then plus 2. And that would give you how many there would be in the 67th figure. Okay, one last, and by the way, before we go on to this last problem, there is more than one right way to do this. And so if you didn't look at it the way I did, if you didn't see, like there's 2 towers and then 1 in the middle, some people might see the 3 across the top, and then these 1 sticking out, and then the 4 across the top, and then the 2 sticking out, and the 5 across the top, and the 3 sticking out. You'll get the same exact answer if you look at it a different way. And in fact, in the next problem, I'll show you 2 different ways to look at this one. All right, so last one. We've got these triangular type numbers. It says how many tiles would there be in the 10th figure, 100th figure, and nth figure. So here's our pattern. Here's the first, second, and third. And so I've got 2 different ways I want to look at this, and I'll show you both ways. So the first way is, so in the first one, we've got 1 on the left, 1 on the right, and then 1 sticking out here. So that's 3. Here I see 2 on the left, 2 on the right, and then 1 sticking out. So it's 2 plus 2 plus 1, which is 5. Here we got 3 on the left, 3 on the right, and 1 sticking out. So 3 plus 3 plus 1. So that's going to be 7. So in the 10th figure, we're probably going to have 10 on the left, 10 on the right, and then 1 up here. So it'd be 10 plus 1. Whoa, scratch that. 10 plus 1, and we get 21. So in the 10th figure, there would be 21 little dots. In the 100th figure, same kind of pattern. There'd be 100 and 100, and then 1 sticking out here on the top. So 100 plus 100 plus 1 is 201. And then in the nth, this was the 100th, in the nth term, this is, you could pick any number for this. You're going to have n on this side. You're going to have n on this side. You're going to have one little guy sticking out here. So it's going to be n plus 1. So 2n plus 1. And you can always check this out. If we're looking at the third term, 2 times 3 plus 1 is 7, and that's exactly what we got. Okay, but when I looked at this a little longer, I saw a different pattern. It's pretty similar, but I looked and I saw this broken up a little bit differently. So I saw these two, and then just 1 sticking off the side. Then on the left, I saw these 3, and then 2 sticking off on the right. And then over here, I saw it as 4, and then 3 sticking off on the side. So I just counted the left, and I included the top, and then I counted the right. And so it turns out to be 2 plus 1, or in this case, it's 3 plus 2, or here it's 4 plus 3. So like in the fourth shape, this would be 1 bigger than 4, so it'd be 5 plus this number, which is 3, so this would be 4. So it'd be 5 plus 4 is 9. So in the 10th shape, I saw it as, well, there'd be 1 more, so it'd be 11, and then there'd be 10 over here, which is 21, and that's what we got the first time around. So in the 100th shape, it'd be 101, and then 100. So 201, and that's what we got first time around. So in the nth, this one, now let's think about what this would be. This would be whatever number it is plus 1, so n plus 1. And then this one would just be that number, so it'd be n. So it'd be 2n plus 1. And that's what we got the first time. So there's more than one way to look at each of these problems. And, each way may or may not be right. I mean, if you do it right, it's right. So don't be stuck on, if you see me do it one way, that your way was wrong. Your way is probably right if you got the same answers. All right, so hopefully this helped clear up how to figure out a pattern, how to figure out an equation from these patterns.